Welcome. This video is CC-BY-CN. All right, so we're going to do some applications. You will need your calculator with you for this for sure, and we will need to verify each time that we are in degree mode for this particular set. Whenever we're doing applications, meaning we're applying the math somehow, we often have to put things in degrees because we're dealing with people, and people understand degrees, and radians are a little harder to figure out. All right, so our first problem here, we have that A is 4, so this side is 4. It says that C is 9. Then they want us to find the two missing angles and the missing side. Let's start with the missing side. We'll use the Pythagorean theorem. So B squared plus 4 squared equals 9 squared. (81 minus 16, 65. I want to point out, it says that the angle should be in degrees and all answers should be rounded to 2 decimal places. So I'm actually going to take the square root of 65 and go to 2 decimal places. Square root of 65. So that's going to be about 2 decimal places, 0.06. So we are missing 2 of the angles as well. So let's separate that out. So I'm going to use the numbers that they gave me. For A, that's going to be the opposite over the hypotenuse. So that's sine of angle A is 4 over 9. Which means that A is going to be the inverse sine. Again, we want to make sure we're in degree mode. So inverse sine of 4 divided by 9. So that's about 26.39 degrees is what I'm getting. And I'm going to use the idea that in all triangles, the interior angle should add up to 180. So I'm going to say that angle B, I could use trigonometry again if I wanted to, is going to be about 180 degrees minus 90 degrees, that's the 90 there, minus the 26.39 degrees. So that's going to be about, so 180 minus 90 minus the previous answer. The way I'm doing that is above here, it says answer ANS. So I'm going to hit second, and then that brings the previous answer, the 26.39 there, but I get all the digits this way. This means I get 63.61 degrees. Not too bad. Find the indicated angle. Now, the only information that we have for this one is the adjacent and the hypotenuse. That's looking like cosine to me. Cosine, let's give this a name, we'll call that theta. It's going to be 5 over 9. I'm going to check again, make sure we're in degree mode. So second inverse cosine of 5 divided by 9. 56.25. So theta, 56.25 degrees. This third one is a little more involved. Actually, these last two are a little more involved. All right, so we have a triangle inside of a bigger triangle. You're probably seeing these two triangles, but I actually want to see this little one here and then the big right triangle, one overall. I'm going to label this side Y, and I'm going to label the entire bottom Z. And then we can see that X plus Y will equal Z, right? X plus Y equals the whole thing. So I'm going to start with the little triangle to figure out what Y is. So for this little triangle, I have the angle is 62. The opposite is 80. The adjacent is the unknown. So that's tangent of 62 degrees should equal the opposite 80 over y, which means y is 80 over the tangent 62 degrees. Let's see what we get there. Degree 80 divided by tangent 62 degrees. There you go. Now you should be doing all these with your calculator while you're watching this video for the practice. It says run to 2 decimal places. I'm actually going to use my memory for this one. I'm going to store this. If you remember how to do that, that's the store button, store alpha, and I'm going to use letter A for that. And to remind myself, I'm going to use my notes. I'll call that A. You could call it Y if you wanted to. Y is down here above the 1, but I used A. All right, so that's part of the puzzle. Now I'm going to find Z. So now I'm looking at this big triangle. So I'm going to take this angle here, and now I know the opposite, the 80, over Z, the whole thing. So that's once again tangent. Not 62 this time, it's 37 degrees equals the opposite, which is 80 over Z, which means that Z is 80 over the tangent of 37 degrees. All right, so 80 divided by the tangent. We're good. Okay, so 80 divided by the tangent of 37 degrees. That's about 106.16. And I'm going to store that as B. So X is still unknown. Y came out to be 42.54. And Z, the whole thing, came out to be 106.16. And this means that X is going to be 106. So that's actually B minus A. So alpha B minus alpha A. Because A I stored in that value, and B I stored in this value. There it is, 63.63, we'll say. And there is no unit on that, so we'll just have to box that as our final answer. All right. From the top of a 167-foot lighthouse, the angle of depression to a ship in the ocean is 19 degrees. How far is the ship to the base of the lighthouse? Now, please note we're not accounting for the curvature of the Earth, which is fine. It's about flat for such a short distance. But I want to draw a picture here. So here we have the ocean. We have the lighthouse, which is 167 feet. And the angle of depression means, and here's the ship. So ship. Angle of depression for our purposes means this angle here is 19 degrees. And if you remember some geometry, when we have two parallel lines like this, we have a line that cuts through it called a transversal. The interior angles are the same. That makes this also 19 degrees. And they want to know how far is the ship to the base of the lighthouse. So that's going to be my unknown. So it looks like we have opposite over adjacent. That is the tangent of 19 degrees is going to be the opposite, 167, over the adjacent, which is X. So that's going to be 167, double check, degree mode. 167 divided by the tangent of 19 degrees. It looks like the ship, and round off to 2 decimal places it says, so 485.00 feet. I know word problems can be a little scary, but these are certainly manageable.